I am Anil Kumar. Welcome to my series on mechanics. We'll discuss moment of forces on rigid body in this particular video. Treat this as an introduction to the unit. Following videos will have in-depth questions and practice test examples. In this video, we'll consider what particles are and what are rigid bodies. So that will help us to understand why we talk about moments when we talk about rigid bodies. So we will have a basic concept of moments in this video. We'll see how do we calculate moment about a point. Based on this, we'll have some practice questions. Now it is important to understand that till now we were considering things where we treated the object as a particle. Now, when you treat an object as a particle, it means what? Particle is an object whose dimensions can be neglected as they are very, very small when you compare them with other objects in the whole system. This really implies that mass of the particle is concentrated at a single point. Since it does not have any dimensions, so that particle will be considered as a single point in every object has a mass, that mass will be at that particular point. Correct? In particle, we also neglect the rotational effect of any force. We say the rotational effect of any force is zero. And of course, effects due to air resistance is also ignored. But when we talk about the rigid bodies, rigid body is a solid body in which deformation is neglected as it is almost zero. That is to say that the rigid body will not bend or get deformed. Now, in rigid bodies, the rotational effect cannot be neglected. So, rotational effect of a force cannot be neglected. They cause turning effect, which is called a moment, and that is what we have. So, to understand this concept, let us say we have a rod. Well, let me just first tell you few types of rigid bodies which we will consider in our examples. One of them you'll come across is a rod. So, rod is a rigid body with one dimension. We'll normally consider this to be length of the rod, but has no thickness, that is to say. Right? So the rod will basically be something like this. So that will be a rod, and we might have uh, length of the rod, right? So let's say length is 10 meters. So that becomes a rod. Thickness is neglected. Now the other rigid object which we'll consider is lamina. So lamina is a rigid object with two dimensions, like a paper. So when we talk about a lamina, it could be any shape actually. So it could be any shape like this, but we'll consider more rectangular in our cases. So those dimensions, length and width, are huge as compared to the thickness, and therefore we neglect the thickness when we talk about lamina. Now, whenever we use the term uniform body, it means mass is distributed uniformly over the entire volume and can be considered to be concentrated at the center of the body. So, this is the geometric center of the body. So, in case of the rod, we can consider the mass to be centered midway, right? Do you understand? It is uniformly distributed, then midway. In this, we'll find the center of the mass somewhere here, and that is where it will be acting. So the mass will be acting at this point. Similarly, in any object which we consider the center, the geometric center of the object will be the point where the whole mass will be concentrated for our calculations. But when we say it is a light object, it means that the mass itself can be neglected. You get the idea. Now, let's get into the concept of moment. If I have a simple rod like this, and if I hinge it from this particular point, right? So, if I fix this point, in that case, the weight due to the mass of the object will cause this body to rotate. And in this case, it will be clockwise rotation, and this clockwise rotation is called the moment, which is focus of our study today in this particular video. Now, if we have a lamina, which is kind of a body shown here, now assume that I apply a force in this direction. That force F will cause, let us say we have hinged the body right there at the center. So this force will cause the body to rotate in counterclockwise direction. You get an idea. So we do see that when we talk about the moments, the rotation could be either clockwise or counterclockwise. Correct? We could apply many forces. We could apply a force in this direction, let's call F1, and another force in this direction, let's call this as F2. We could apply many forces on an object, and that will result into some resultant force, right? So we may have to work out this example to see in which direction will there be a rotation about, let's say, this point P. Well, necessarily, the point may not be at the center. It could be any point on the object. So that is what we are going to study now. But let's first understand what the moment exactly is, right? Moment of a force is a measure of the turning effect produced by the force on the rigid body. This force causes rotation about the pivot and so must include the direction of rotation as clockwise or anti-clockwise. So if we have any object, so think like this, that we have this object here which is kind of like this. So within this object, we are considering a particular point P and we are applying force in a particular direction shown in this green line. In that case, it will cause a rotation about the point P, and that is the moment. And we are going to calculate what this rotational force effect is. So the moment of a force F about a point P is the product of the magnitude of force F and the perpendicular distance from the pivot P to the line of action of the force. So important thing is to the line of action of the force. Now force is a vector quantity. So when I apply this force, we are always considering the line of action of the force. And this distance considered will be the shortest distance, correct? So perpendicular distance will be always shortest distance. So as you have seen here, from the point to the force, line of action of the force, we are considering the shortest distance, d. When you multiply force and distance, you get the measure of moment. Plus, you have to also mention the rotation. So it is measured in Newton meters because Newton is the force and meters is the distance, and the direction of the rotation should be mentioned as clockwise or anti-clockwise. So the moment m of a force F about a point P is the magnitude of the force times the distance. Well, those students who are doing vectors, for their moment is a cross product of force and distance as shown above. So cross product actually takes into consideration about the shortest distance, the perpendicular distance. So if the force is, if we are given some other distance, let us say if we are given, let's say some other distance, let's say from here to here, Then you can find the shortest distance by finding the sine theta value. We'll take up this in examples. Now, with this concept clear to you, let us look into some examples and calculate the moment. So, the very first example is calculate the moment about the point P of each of these forces acting on a lamina. So, lamina is a two-dimensional body where the thickness is neglected. So, consider this whole page as the lamina. So, we have a point P and the force is acting of 5 newtons, which is at a distance of 2 meters from point P. So, in that case, what is the moment? So, as we have learned, the moment is the product, right? So, you can calculate this. So let's do this calculation. So the moment about point P, let me write this as m of at point P, will be the magnitude of force, which is 5 newtons, times the distance, right? So in this case, we are given 5 newtons times 2 meters, and that gives us the answer 10 Newton meters. Another important thing is that this force is going to cause a rotation, and so we need to mention this rotation also, which is counterclockwise or anti-clockwise. So we can write down this rotation as here as rotation, say counterclockwise. So that will become part of our answer. Is that clear to you? Perfect. So using the same concept, you can solve question number 2 and 3. So clearly here, the rotation will be what? Since the force is being applied here and the point is given to you in this position, so the moment is going to be clockwise. So we can write clockwise moment. And the magnitude is 7 times 3. Do you see that? Which is 21 Newton meters. So that is how you can solve these questions. Now, question number 3 is we are given a point and the force of 4 newtons. The point is 1 meter from the given thing, right? Given force. Okay, but it's very important to note that this force is going through the point and the shortest distance is 0, right? So distance d equals to 0. And therefore, in this case, the moment about P is 0. You see that? So if the force goes through the point, in that case, the moment will be 0. Very important concept to remember. So here are our solutions just now which we did. So in the first case, it is 5 times 2, 10 Newton meters. Anti-clockwise is the direction, right? So this goes in anti-clockwise. Here we have 7 and 4. 7 times 3 is 21 meters and the direction is clockwise. In this case, it is 0 since the force acts through the point itself. So I think all these concepts are absolutely clear, right? Now let us take up examples where the distance given to you is not the shortest distance. So here we need to calculate the moment about the point P of each of these forces acting on a lamina. Line of action of the force to the point is shown. So this blue line shown to you is the line of action of the force. And the angle is given to us, not the shortest distance. So can you take a moment to answer this particular question? So you can pause the video and answer the question. Now here you need to calculate the shortest distance, right? So the first thing is you have to calculate the shortest distance. How will you do so? Shortest distance is the perpendicular distance. So from this point to the force, so we can actually draw a line going perpendicular, right? So that becomes the shortest distance. You see that? Now in this particular triangle, this is the opposite side. So we can write down that sine of 30 degrees is equal to, let's call this point as M. So in that case, that is the opposite side. So it is PM over Let's call this point as AP, which is 6 meters given to us. So we can say that PM is AP sine of 30 degrees. Is that clear to us? AP is 6, and what is sine of 30 degrees? You can form the special triangle and find what sine of 30 degrees, or you can use your calculator, correct? So either one. So that is 30 degrees for us. In that case, it is half. So it is times half. So that gives you a distance of 3 units, which is in meters. 3 meters. And we know that the force is 5 newtons. Therefore, the moment about the point P is 5 newtons times 3 meters. And that gives us 15 Newton meter. Is that correct? And the force, since it is being applied in this direction, it will cause a clockwise direction, right? So the direction is clockwise. That is how you are going to answer this particular question. So I hope this is absolutely clear. Now here is question number 5, where again we have given you a diagram where the force of 6 Newton is being applied and the line of the force acting along the point P is shown at an angle of 120 degrees. And the distance from this point, let's say this point A, is given to us as 4 meters. Now in this particular case, you need to find the moment due to the force of 6 Newton about the point P. How are you going to do it? So here, to find the shortest distance, let me just say that this is my shortest distance, correct? So in that case, what is this angle? Well, 120 is the total angle. So 180 minus 120 will give you 60 degrees, correct? So 60 degrees becomes that angle. Hypotenuse being 4 meters, so the opposite side, let us say PM in this case, will be equal to 4 sine of 60, right? So the distance D, let me say distance D, is basically equal to 4 sine of 60 degrees. And force is given to us as 6 newtons. And therefore, the moment at P will be product of force and the distance, which is 4 sine, let me write 6 newtons first, 6 newtons times 4 sine theta, which is 60 degrees in meters. So that gives you the force. Now sine of 60 degrees, that is the 60 degrees angle, correct? Is square root 3 over 2. So that gives you the values as 6 newtons times square root 3 over 2, which is the sine value times 4 in meters. And the direction will be what? Well, this is the force. So this force will move it in anti-clockwise direction. So you can do this calculation and write down the result. But I hope with this, the steps are absolutely clear. Perfect. Here is the solution for you, neatly typed out. Okay. So as we discussed, when you are given the distance, which is not the shortest distance, you need to calculate the shortest distance. So if you are given the angle as shown here as 30 degrees, the opposite side relates with sine theta. So you have to use trigonometric ratios to find the shortest distance. So in this case, we figured out that it should be 6 sine 30 degrees to give you the value of the shortest distance. Multiplying distance with the force given gives us the value in Newton meters. And we have to include the direction. So in this case, the direction is going to be clockwise. So we'll say clockwise. Right? So rotation, clockwise rotation, has to be mentioned in the solution. Clear? The next one here is the force is given, and we saw that this force will act in counterclockwise or anti-clockwise. So we'll write this as anti-clockwise rotation. With the force being 6 newtons and the shortest distance, we worked out with the angle. So 180 degrees minus, so this angle theta is basically equal to 180 degrees minus 120, correct? Which gave us 60 degrees. Side opposite gives us the distance, which is the shortest distance, and sine theta is the ratio which is to be used. And we get our answer. Is that clear to you? So with that, we come to an end with some practice questions for you. Here are three questions which you can solve. Calculate the moment about the point P of each of these points acting on aluminum. You can solve these questions and send me the solution by the email. I can always check and give you the response. So in this particular video, we learn what are particles and why we were not considering moments about particles. Since their dimensions are negligible, the rotational effects are neglected. But in rigid bodies, we cannot neglect the rotational effects which are caused by the external forces. So there we are considering the moments. When we consider moments, we have to always write down the answer with the direction of rotation. So that is kind of very important to understand. And so when we did the calculations for the moment about a point, we mentioned that the moment will be in Newton meters and will have a rotation. And rotation direction should be mentioned. Well, as far as the rotation is concerned, you could consider positive for either clockwise or counterclockwise. And then we had some practice questions. Here are two practice questions for you, which you can take as a test. So, what we will do here is, let's say we'll take one with the rod and one with the lamina. So, one with the rod and one with lamina. So in case of a rod, let us say we have a rod here and the mass of the rod is acting here and this mass is, let's say, 10 newtons. We need to find the moment at point A, but we also have a force acting here of, let us say, 4 newtons. Force of 4 newton and the distances given to us are: the force acts at 6 meters distance and the length of the rod is, let us say, 8 meters. Correct. So that becomes one of your test questions. So I'll call this as question number 1 for the test. And the question number 2 here is that in a rigid body, let's say this is our rigid body, right? So in this rigid body, we have a force which is acting here. We're considering a point which is somewhere there. We'll give you the distance between the force and the point, which is, let us say, 2 meters. The force F is, let us say, 6 newtons. But we have another force acting in some direction, let us say, right? So the shortest distance is not given to us, but we are giving this particular distance and the angle of the force. Let's say the angle of the force is 45 degrees. And the distance is 1 meters. So we want you to find the moment about the point P by the forces as shown in the figure. So we are considering two forces in both the examples. One due to the weight of the body itself, which is a rod in the first case and a force, and the other one, we have two different forces acting, and we're talking about a point in the rigid body. So try to read these examples. We'll take them up in the next video. I hope with this you get the whole concept. We definitely will be working with much more complicated examples, but if you can work with a single force and a single point, I think you can do with multiple forces also. So with that, we end our video. Thanks for your time and all the best.